I'd like to share some of the excitement I have with you and maybe some of the requirements to make this a success. So at the end, I'm going to try to give some success criteria that led us to where we are today. So what you see is a very slow animation right now. Activities on nanoHUB throughout a week in February of last year. You see blips. Basically, it's a 24/7 operation across the globe. And what I want to talk about is my talk. Talk about the stakeholder needs to make this a success, and then really try to show how we busted through some perceptions that are existing in the community to make this work. So it's also instructive to look at a sort of a global map that's static. So basically, we have about 250,000 users across the globe. Basically, we're keeping people up at night wherever there's infrastructure that keeps up the night sky lit. We've been in operation for about 12 years or so, and we made changes, and we changed systems, and we saw reactions in users when we moved from sort of a web form type computing to interactive computing, and we saw significant growth right there when it was changed. We introduced lectures on nanoHUB, and basically since 2009, we've been a MOOC with 100,000 users that look at lectures and tutorials and seminars that go along with all of the simulation stuff. So in 2007, we spun out Hub 0 out of nanoHUB, and then now we have some 40 hubs that are operated on the same infrastructure and many fields of science that really cut across all kinds of areas of science and data and simulation. So in this process of doing this over the last 10 years or so, I've noticed that the community, my community in electronics and simulation, really has a lot of perceived myths. So one of the myths, and they're really grouped in three different groups of people: the users, the developers, and the operators of such an infrastructure. And the user community really thinks that you can't really use research codes for education, or you have to write your own research code to do real research, or experimentalists will never touch this. It's just almost written in the ground that is not possible. On the developer side, people think that building a user interface or metadata is really hard, and you can't overcome that, and there's no incentive, and you have to rewrite things to put them on the web. It's really hard to do, and there's no incentive. And on the accessibility side, there really was no end-to-end science cloud that existed as such 12 years ago. I don't want to pick up these myths, but really what you have to think about is that you really have three different stakeholders in this party, so to speak. You have suppliers, you have customers, and you have a market. And you have to meet the needs of all of these very different stakeholders in order to make this a success. So I'm going to talk about these developers. I'm just going to show you a result, right? One result is we have now 270 interactive tools online developed by 380 independent developers in the nano community. And that was done by a technology we call Rapture that allows people to create or wrap their applications in a metadata descriptor that automatically gives them a user interface, and it makes it easy to use and easy to manage. And then Hub 0, the infrastructure that hosts all of that. And just since we're talking about collaborations, I wanted to highlight something here. So here you have 380 dots on this screen. These are the 380 people that are interacting with each other to build tools. And the interactions are shown by these white lines that cut across. And the colors mean where they are. The really interesting thing is here in the middle, the turquoise one, are people we have in principle nothing to do with. They come from the outside. They're not part of the internal network. And now the question is, when you see linkages like that in your supplier network, is there an impact? Now you can quantitatively ask, if you measure these people's interactions against impact on users, and you plot, for example, here, number of collaborators a person has in their tools versus the users they serve, you see a pretty dramatic increase if you have a lot of collaboration. In fact, you should put this on a log-log scale, and you'll find it's almost a straight line. Meaning you want to be in the top right with lots of collaborations, and you will have a lot of impact. Now, these are the median data. What I really want to show you is the 280 dots, 380 dots, which each individual is being represented on. And what you see on the higher end up here, with lots of collaboration, the scatter is very small, versus on the bottom, it's almost a crapshoot whether you're going to be successful or not. Meaning, in the bottom here, on the lower left, you already have small collaborations, you have scattered success. Versus if you're on the top right, you have large collaboration, you almost get into the predictable success. So that's and this is data, right? Now, I'm not making up a dream that this might be a good thing to do down the line, possibly eventually, right? This is still data. All right, so I go back to this animation. Apparently, we are accessible. I would argue nanoHUB is the first science cloud where everything is done completely in the cloud, where users have no idea where these simulations are being run, where, how, when. But now that we have a market, we have customers, apparently. Now the question is, what are they doing? And you have to put that in light that you can't use this for education, right? And you can't use this for research, because those are the things I was told by NSF panels that this is possible to do, which are good comments, right? I'm not dissing that. I'm just, now you have to provide data that this you have overcome this. So one way to look at that is look at the matrix of usage on nanoHUB when we analyze people's behavior. And what we see here on time is horizontal axis, vertical is we stack people up. So they show up, say, in this one group up here in the top right, there's one group that shows up once. There's a whole group that shows up throughout the whole semester, use one tool, here's spring break in the break there. And then there's another group maybe that looks like one tool, 2, 3, 4, 5, 6 different tools. We can measure the classroom size by people behavior without them telling that they're in a class. So that's kind of cool. They're in many different areas. There's freshman and chemistry. We have researchers that behave completely erratic. So, but the point is, we have now over 19,000 students and 1,000 courses or clusters like that at 105 institutions that take off virally, voluntary. I'm not going around telling people, why don't you try? It's really happening. So these are research codes being used in the classroom. Right? This myth that you can't do that is busted by other people, because they do. We can talk about time of adoption and all that. I have really nice data, but no time. We can't do research, right? It's a myth. Well, we start to search through the literature. We have over 1,000 citations of nanoHUB in the literature, which generate an impact factor of 48. So they're pretty good publications. The really cool thing is 77% of the people that publish with nanoHUB are outside of the inner network, which is a really good thing. And I want to highlight the importance of this graphical user interface. So we did web pages that are kind of what your bank has still today, or what most science gateways have. Like you fill out a form, you click a button, you get a GIF image you can't do anything with, right? Or you have to download the data yourself into your own machine, charge it, and do your work there. So we have that. One example here is a tool Shred. We have 5 users about monthly, then a couple of poor suckers that use this in the classroom. And then we changed the system to be interactive, and suddenly we see a little bit of growth on this one tool. And what's even more astounding is we track also, this is an open source code in this case, we track the downloads of that open source. And it drops, meaning people really aren't that interested in housing a tool and maintaining it, right? They want to use it. And this is not that unusual, right? I don't know if you remember the days when an iPhone was introduced, on iPad, all the techies said, well, this is a crappy camera, it's an ARM processor, it can't do anything compared to another product. The point is, these things have changed how we access computers today because they're usable. They may not be as capable as some other pieces of hardware, but they're usable. And that's the key success of Science Gateway, usable customers. All right, so many portals have promised knowledge transfer. The question is, why is this so hard? Why do people not succeed in general with that? And it's because between research and the real world, you have this valley of death that you have to overcome. There's really little incentive to bring this stuff over. And part of the problem lies in our typical dissemination path. What we do is we work here, right? We have a research team. We work in tools or data or instruments. Then we generate maybe some knowledge, some IP, and publish it. And we bring that to our customers, which are peers that sit on a different planet. So Then we might do this a couple of times. We create a local course for local students that sit on a different planet. And then we do this really successfully. We might write a textbook about this that taught to students that also live on similar but different planets. And the problem is we all have web pages. Everybody has a web page, right? And how out of date is it? Because it has nothing to do with what you really do. It's completely out of sync. So the point is, what nanoHUB does, it embraces all of this. The whole process of generating knowledge, the data, tools, the modern textbooks of having lectures and courses online, and guess what? The users come to you. So you can scrap that independent web page. All right, so what are the 7 criteria to make this successful? One is kind of a dot, right? You have to have outstanding science. But there's a line to that, lots of it, meaning much more than NSF will ever give you on a single project. Okay, got it, sorry. So that means you have, in our project, we have like a 1.5x associated funding more that we weren't given from NSF in order to create all this content. So you've got to rope in people that really buy into this. Number 2 is you have to have commitment to dissemination. That's different from having the content. You have to have people that really want to give it away. You've got to develop incentives to do so. And we've tried to develop incentive systems to do so. So here's an example of Dragica. She wrote this thread tool I talked about. And every contributor on nanoHUB gets the chart like this. So she serves some 11,000 users. The tools are cited 123 times. I think that looks kind of good on proposals for NSF because she's not dreaming of an outreach program, right? This is hard data. She'll say, I'm going to improve on what I have done already. So here's an example of a younger person now, former postdoc in my group, wrote some 8 tools, 6,000 users. He went to Southern Illinois. Suddenly, Southern Illinois, which was basically silent on nanoHUB, has a lot of pickup of usage. He integrates nanoHUB into his classrooms, builds new curricula, and he gets promoted with tenure after a really short time, within 2 years, and nanoHUB is attributed to that. So we're building incentive systems on why you want to do. 3, technology. So nanoHUB builds the bridge. In the terms of technology, it's not cheap to operate. So if you think you want to just run a little hub on the side, it won't happen. It's really an expensive thing to do. Then the really expensive thing is you have to have people that are at a PhD level that help these faculty to carry the stuff over. And that's really where we spend a lot of our money. It's the reaping of the research content. And call them consultants, whatever you want to call them, but they are needed to help this process. Then you really have to bring all of these needs together by the developers, the users, and then you build multiple vibrant virtual organizations in one box. It's not just one organization. It's many people with different incentives and interests. Then you have to have this, I think you have to have this assessment. We basically have 1 to 2 people working on this kind of assessment all the time to try to tell the success stories and the data. 7, the business model. You can't just create a hub for 2 years. That's insane. So you have to create it with something that's sustained and build a sustainability model. So here are the criteria listed out, and ask me later about link of research and education, how we're going to host the data and interactive journals.